Okay. Pleasant afternoon to everyone. Start na ako, no?
Afternoon po, sir.
Okay. Yeah, our topic for today is fluid mechanics pa rin, no? Continuation yung last topic natin last week. Okay? So, start muna tayo sa continuity equation. So, fluid mechanics 02 parang related siya sa pumps and sa fans and blowers. Kasi yung concept dito, no, parang kaparehas lang doon sa IPE natin. Okay, so start tayo with continuity equation. So for incompressible fluids, the volume flow rate at steady state is constant in any section of the pipe. So yung Q natin at incompressible fluid is constant. Q1 is equals to Q2. Pwede mo siyang i-write as area 1 times velocity 1 is equals to area 2 times velocity 2. Okay? So for circular pipe, yung area pwede mong i-rewrite as pi over 4d squared v1 is equals to pi over 4 d2 squared v2. Or yung pi over 4, makakancel lang siya, no? So ang magiging formula natin is d1 squared v1 is equals to d2 squared v2. Where yung ating velocity is 4q over pi d squared pa rin. Okay? For compressible fluids, ang constant naman natin is yung mass flow rate. So M1 is equals to M2, where yung M mo pwede mong i-write as density times area times velocity. Then Reynolds number is a dimensional parameter equal to the ratio of inertial forces to viscous forces. So formula natin ng Reynolds number is equals to inertial force over the viscous force. Okay? So ito yung ginagamit natin para ma-predict natin yung type of flow ng fluid, either laminar or turbulent. So recall lang natin dynamic viscosity is equals to kinematic viscosity is equals to dynamic viscosity divided by density. Since Reynolds number is inertial forces over the viscous force, pwede natin siyang i-write as velocity times diameter over the kinematic viscosity. Yung velocity na gagamitin mo dito is yung mean velocity. Okay? Then, yeah. Since kinematic viscosity is dynamic viscosity divided by the density, pwede mo siyang i-rewrite as density times mean velocity times diameter over dynamic viscosity. So, ito yung formula natin for Reynolds number. Okay? Pag kino-consider natin yung non-circular cross-section, ang formula ng Reynolds number is 4 times mean velocity times hydraulic radius divided by gamma. Okay? Where yung ating hydraulic radius is equals to area divided by wetted perimeter. Ibig sabihin ng wetted perimeter, yung perimeter ng iyong section na nababasa ng tubig or ng fluid. Okay? Like for example, meron kang meron kang spear. Tapos wait lang, lolo ko nga. Ito na lang siguro. Like for example, meron kang spear, tapos merong lamang na tubig. So yung wetted perimeter mula dito hanggang ito lang siya. So yan yung consider mo. Okay? So ganun siya. So yan yun. Okay. So for non-circular cross-section, yung diameter mo is 4 times uh, hydraulic radius. Kaya siya naging 4 BRH over gamma. Okay? Now, for the type of steady flow in pipes, meron tayong tatlo. No? So, check mo nga to by using Reynolds number. So, kapag ang Reynolds number mo is less than or equal to 2,000, considered siya as laminar flow. Kapag greater than 2,000 but less than 4,000, ito yung transition zone. And kapag greater than 4,000, ito yung turbulent flow. Okay? Where yung sa ating nozzles, for critical velocity, automatic Reynolds number natin is equals to 2,000. So, okay. So, yan na lang muna. Reynolds number muna tayo. So, try natin yung example number 1. Number 1, the mean velocity of 40-degree water in a 44.7 millimeter inside diameter tube is 1.5 meters per second. The kinematic viscosity is 6.58 times 10 raised to negative 7 meters squared per second. What is the Reynolds number? Okay, so for number 1, kunin natin yung given. So meron tayong mean velocity of 1.5 meters per second. And ano bang kailangan natin sa Reynolds number? Hindi na yung temperature, diameter na lang, tapos velocity, tsaka kinematic viscosity. So diameter of 44.7 millimeters, convert natin ng meters, 0.0447 meters. Then kinematic viscosity of 6.58 times 10 raised to negative 7 meters squared per second. So ang hinahanap dito ay Reynolds number. Okay, so formula natin ng Reynolds number in terms of kinematic viscosity. So we have velocity times diameter over kinematic viscosity. So direct sub lang to, more on cancellation of units. So Reynolds number is equals to velocity 1.5 meters per second, diameter of 0.0447 meters, kinematic viscosity of 6.58 times 10 raised to negative 7 meters squared per second. So Reynolds number, unitless dapat yan. Okay? So meters squared second. So therefore, ating Reynolds number ay 1.5.0447 over 6.58 times 10 raised to negative 7. Okay. So naka-exponent yung ating choices. Press natin yung eng. 101.899. So press natin ulit yung eng. Shift eng, shift eng. Okay. So pag nag-eng kayo, ang raise ng power mo is raised to 3, raised to 6, raised to 9. No? So divisible by 3. Iurong mo na lang ng isang decimal place. So yung sagot dito is letter D, 1.02 times 10 raised to 5. So considered siya as turbulent flow kasi greater than 4,000 yung Reynolds number. Okay, okay, so number 2. Number 2, a fluid with a kinematic viscosity of 2.5 times 10 raised to negative 5. So copy ko lang. Kinematic viscosity of 2.5 times 10 raised to negative 5 feet squared per second is flowing at 0.1 feet per second. So yan yung ating velocity. 0.1 feet per second. from the orifice 3-inch in diameter. So meron tayong diameter of 3-inch. How can the fluid be described? So number 2, under siya ng elements, no? Pero gagamitan mo siya ng solving para makuha mo yung sagot. So gagamitin natin yung Reynolds number para ma-determine natin kung anong type ng flow yung fluid natin. Okay, so Reynolds number is equals to velocity times diameter over kinematic viscosity. So velocity natin is 0.1 feet per second. Diameter is in terms of inches, convert mo ng feet. So 3 over 12 feet divided by kinematic viscosity of 2.5 times 10 raised to negative 5 feet squared per second. Cancellation of units, dapat unitless yan. Okay. So 0.1 times 3 over 12 over 2.5 times 10 raised to negative 5. Okay, so therefore, Reynolds number is equals to 1,000. So kapag 1,000 ang Reynolds number, considered siya as laminar flow kasi less than 2,000 siya. Therefore, from choices, okay. So, letter A, hindi na kasi hindi naman siya turbulent. Letter B, hindi rin siya transition. So, either letter C or letter D. So, letter D, the fluid is turbulence cannot be calculated from the information given. Okay, so X yung letter T. Correct answer is letter C. The fluid is laminar. Okay. Then number 3. Number 3, oil has a specific gravity of 0.8, flows in a 200 millimeter diameter pipe. Find the critical velocity if viscosity is equals to 8.14 times 10 raised to negative 2 Pascal second. Okay. Kunin natin yung given. So, meron tayong specific gravity of 0.8. Meron tayong diameter of 0.2. 0.2 meters. And also, meron tayong viscosity. So, as I said nung previous na lecture, no, kapag walang sinabi kung anong viscosity siya, automatic dynamic viscosity yung default natin. So, 8.14 times 10 raised to negative 2 Pascal second. So, ang hinahanap dito is the critical velocity. Okay. So, balik tayo doon sa ating, sa ating concepts. So, kapag critical velocity, automatic yung iyong Reynolds number is equals to 2,000. So, since critical velocity, Reynolds number is equals to 2,000. So, gamitin natin yung formula ng Reynolds number in terms of dynamic viscosity. So, ang formula natin is, ito na, density times mean velocity times diameter over dynamic viscosity. So, since meron tayong specific gravity, no? So, gamitin natin siya. So, specific gravity times density times velocity. So, critical velocity na siya. Kasi yung Reynolds number na gagamitin is 2,000. Okay. Times diameter divided by dynamic viscosity. Okay, so 2,000 is equals to 0.8 density natin. So, oil is liquid, so density ng water, 1,000 kilogram per cubic meters times the critical velocity, yan yung hinahanap, times diameter, 0.2 divided by dynamic viscosity of 8.14 times 10 raised to negative 2. Unit ng Pascal ay Newton per meter squared, then copy mo yung second. So Newton second per meter squared. Okay. So cancellation of units. So Newton is kilogram meters per second. Ano? Okay. So maka-cancel to. Isa na lang to. Cancel si kilogram. So itong dalawa maka-cancel. So magiging isa na lang yan. So unit natin dyan ay meters per second. Okay, so 2,000 times 8.14 times 10 raised to negative 2 over 800 times point. Okay, so 1.0175. 1.0175 unit natin ay meters per second. So letter A yung sagot. Okay. Yeah. Okay, number 4 tayo. So number 4, what is the hydraulic sen? What is the hydraulic radius of the semicircular channel shown? Yeah. Okay. So pag sinabing hydraulic radius, ito yung may may wetted perimeter, yung diniscuss ko kanina. So ito yung formula na gagamitin natin. Okay. So i-check lang natin yung given. Okay. So yung given natin nasa figure. So kung i-analyze natin yung figure, ang makukuha natin dito is yung area ng segment. Ano? Kasi ito daw yung channel na may tubig. Tama. So i-ano ko lang. Drawing ko lang in terms of yung sa given. Ano. Mayroong drawing naman dito. Teka. Yan. Yan, pwede na yan. So yan yung ating figure. Ano. So since 70 degrees to, pag kinonsider mo to, magiging 140 degree. Okay. Then ito 1.2 feet. Ito 1.2 feet. Then ito nga yung ano natin, yung wetted region natin. So yung wetted region natin is in terms of segment. So para makuha natin yung area niyan, area ng ating segment, so balik tayo ng ano no, balik tayo ng tawag dito, solid geometry. So area ng segment is equals to area ng sector minus area ng triangle. Okay. So anong formula ng area ng segment? Area ng sector pala. So pi r squared theta over 360 kasi part lang naman siya ng circle. So i-ratio na lang natin yung theta divided by 360 degree. Okay? Area ng triangle is 1/2 a times e sine theta. So ito yung 1.2 feet. Ito yung A mo, then ito yung B mo. Parehas lang naman siya ng size. Okay. So check natin yung given. Direct sub na lang siguro ito. No? Ito naman eh. So area ng segment natin is pi. R natin is 1.2, no? Yan yung ating radius. So 1.2 squared feet squared. Theta natin is 140 over 360 minus 1/2 1.2 times 1.2 feet squared sine theta natin is 140. Okay. Therefore, area ng segment is equals to so pi 1.2 squared 140 over 360 minus 1/2 times 1.2 squared times sine 140. Make sure na yung angle nyo ay naka-degree. Okay. Okay. So therefore, tama ba? Pi 1.2 squared 140 over. Okay. Then minus. Bakit 1.2? 1/2 dapat. Minus 1. Wait lang. Kurahin ko lang ito. Minus 1/2. 1.2 squared sine 140. Okay. So 1.296. So 1.296 feet squared. So yan yung area ng ating segment. Okay? Okay. Then ano pa bang kailangan dito? So nakuha na natin yung area. Kailangan natin is yung wetted perimeter. So based dito sa ating ating free body diagram, yung wetted perimeter or yung perimeter na nababasa ng fluid is ito. So mula dito hanggang dito, no? So yan yung ating arc, length of arc. Length of arc is equals to wetted perimeter. So balik ulit tayo ng solid geometry. Formula ng arc. Arc is equals to wetted perimeter. So perimeter ng circle 2 pi r, then ratio lang ng angle. Okay. Yan yung simplest na formula. Okay. So 2 pi times 1.2 feet times theta natin is 140. Tama. Okay. 140 over 360. So wetted perimeter natin is equals to 2 pi times 1.2 140 over 360. Okay, so 2.93 feet. okay na, may area ka na, mayroon ka ng wetted perimeter, masasolve mo na si RH or yung iyong hydraulic radius. So RH is equals to area ng segment over wetted perimeter. So 1.296 feet squared divided by 2.93 feet. So unit-wise, unit mo dito ay terms of feet. 1.296. Okay, so therefore, hydraulic radius is 0.442. 0.442 feet. Okay. Check natin sa choices kung tama ba ang magagawa natin. Ayan. So letter A, 0.44. Okay. Okay. The next item. So ito, nasa ano ata to? PIP. Parang palagi ata siyang lumalabas sa board exam. Ilagyan niyo ng PIP. Okay, so number 5, an engineer needs to deliver 150 cubic feet per minute of water in a round pipe in such a way that the flow in the pipe remains laminar. If the critical Reynolds number is 2000, what is the diameter of pipe that is necessary to ensure laminar flow? So take note that the kinematic viscosity of water is 4.75 times 10 raised to negative 5 feet squared per second, and assume that the flow in the pipe will be uniform. So kunin natin yung given, number 5. So 150 cubic feet per minute, yan yung ating volume flow rate. So Q, no? 150 cubic feet per minute. Okay. Then, meron tayong Reynolds number of 2,000 since critical yung na-measure ng ating engineer. So, RE 2,000. Then, also meron tayong kinematic viscosity of 4.75 times 10 raised to negative 5. Ang unit natin is feet squared per second. So, ang hinahanap dito ay what is the diameter of the pipe. So, T ang hinahanap. Okay. So, since Reynolds number pa rin siya, no? Ito yung formula na gagamitin natin. Reynolds number is equals to velocity times diameter over kinematic viscosity. RE is equals to velocity times diameter over kinematic viscosity. Okay? Pero wala kang velocity and wala kang diameter na. Ang meron ka lang is kinematic viscosity and Reynolds number. So isosolve muna natin si velocity. Formula ng velocity natin is 4q over pi t squared. So hindi mo rin masasolve si velocity kasi wala kang diameter. Tama. So i-ano mo lang to, i-plug mo na lang siya dito, no? Yung velocity. Okay. So, okay. Reynolds number is equals to velocity 4q over pi t squared times diameter divided by kinematic viscosity. So, cancel natin yung diameter. So, isa na lang to. Let's cancel to. So ang ating magiging working formula ay 4Q over pi times diameter times kinematic viscosity. Then check natin kung kaya mo siyang isolve. Meron kang Q, meron kang kinematic viscosity. Ito yung hinahanap. Meron kang Reynolds number. So kaya na kasi one unknown na lang. So i-direct sub na natin. So Reynolds number is 2000 equals to 4 times Q. Q natin is 150 cubic feet per minute. Convert na natin into second. So 1 minute is equals to 60 seconds. Then pi times T times kinematic viscosity of 4.75 times 10 raised to negative 5 feet squared per second. By cancellation of units, cancel C, cancel C second, so ito isa na lang. Okay, so unit natin dito ay in terms of feet. So therefore, diameter is equals to 2000 is equals to, so 4 times 150 over 60 times pi times alpha x times 4.75 times 10 raised to negative 5. Okay, so diameter natin is 33.506. Unit natin ay feet. Check natin anong letter siya. 33.506. So letter A. Okay. So yan na yung about sa Reynolds number. So proceed tayo sa next topic, which is yung so next topic natin ay energy and head flow. Okay, na-discuss ko na to sa pumps, no? So hindi ko na masyadong i-elaborate. So kapag kinetic energy and velocity head, i-divide mo lang siya sa 1 over work, no? So work mo is mass times gravity. Kinetic energy is 1/2 mv squared, makakancel yung mass. Therefore, formula mo ng velocity head is p squared over 2g. Kapag potential energy in terms of elevation head, so same lang din, no? I-divide mo siya sa work. Work is mass times gravity. Potential energy is mass times gravity times c. Kaya ang elevation head natin in terms of potential energy is in terms of c, or yung height, or yung datum. Then pressure head, ganun lang din, no? Pressure head is p over gamma. De-divide mo lang din siya ng work. Okay. Then total energy of flow, ito yung sum of kinetic and potential energy. Okay? So total energy of flow is equals to kinetic energy plus potential energy plus energy of flow. Where total head natin is equals to velocity head plus pressure head plus elevation head. Okay. So according to Dr. Bernoulli, applying the law of conservation of energy to fluids that may be considered incompressible, Bernoulli's theorem may be stated as follows. So neglecting head loss, the total amount of energy per unit weight is constant at any point in the path of flow. So pag nineglect mo yung head loss, sabi ni Sir Bernoulli, no, yung energy natin per unit weight is constant. So energy 1 is equals to energy 2. So energy is equals to P squared over 2G plus P over gamma plus C. So in terms na to ng head, ano? So total dynamic head na siya. Then, ito na-discuss ko na rin to, no? Yung Bernoulli equation. So hindi ko na siya masyadong elaborate. So ito lang yung nadagdag dyan. Yung energy grade line, ito siya, no? Yung pa-horizontal line. Kita nyo? Yung EGL. So pag tinanong sa problem, what is the energy grade line? Ang formula natin is P squared over 2G plus P over gamma plus C. Pag tinanong yung hydraulic grade line, ito yung pa-curve, no? Ito sa ating diagram. Hydraulic grade line is equals to P over gamma plus C. So nawala yung velocity. So hindi mo kinonsider. Okay? So yun lang naman yung kaibahan ng dalawa. Energy grade line, consider mo yung HP, velocity head. Kapag hydraulic, walang velocity. So energy equation with pump, na-discuss ko na rin to. Ang nadagdag lang dito, kapag meron kang H ng pump, dito mo siya ilalagay sa left side of the equation. Yung head loss nasa right side. Okay. So kapag turbine naman, head loss and head ng turbine parehas nasa right side. Okay. Then major head losses and pipe. So ang gagamitin mo dito is yung kapag major head loss. Yung Hagen-Poschul formula. So H loss is 32 times dynamic viscosity times length or pipe length times mean velocity divided by specific weight times diameter squared. Where gamit na gamit pa rin dito yung Darcy's equation and Morse equation. So as I said doon sa pumps, no? Default formula kapag head loss sa pipe ay Darcy. Kapag gagamitan mo siya ng Morse table, Morse equation ang gagamitin mo. Okay? So para may mga case na hindi binibigay yung F or yung coefficient of friction sa problem. So makukuha niyo yung coefficient of friction by using this formula. So 64 divided by the Reynolds number. So in case lang na hindi binigay ano, pero pag binigay yun yung gagamitin niya. Okay. Then minor head loss is equals to K times P squared over 2G. So kapag naka-series yung ating pipe, yung ating volume flow rate is constant. So pare-parehas lang yan. So Q1 is equals to Q2 is equals to Q3. Where yung ating head loss ay summation kapag series. So head loss is head loss 1 at 0.1 plus head loss at 0.2 plus head loss at 0.3. Pag nakaparallel naman, so baliktad, ano? Parang sa ano lang to, no? Sa basic electrical. So kapag parallel, ang iyong volume flow rate ay summation. So Q1 plus Q2 plus Q3, where yung ating head loss naman ay constant. So head loss is HL1 plus head loss 2 plus head loss 3. So try natin gamitin sa number 6. So number 6, consider the water flowing through converging channel as shown and discharging freely to the atmosphere at the exit. What is the gauge pressure at the inlet? Assume the flow to be incompressible and neglect any frictional effects. So ito na pala yung given. Ano? So meron tayong given. So diameter at inlet is 150 millimeters. Convert natin ng meters. So 0.15 meters. Velocity 1 at inlet, 1.2 meters per second. Diameter at outlet or diameter at exit is 75 millimeters. Convert natin. So 0.075 meters. Then pressure 2 natin or pressure at exit is pressure atmospheric or 101.325 kilopascal. So ang tinatanong dito is what is the gauge pressure at the inlet? So P1 yung nawawala. Okay. So since flow na ito, no, gagamitin natin yung Bernoulli's equation. So formula natin ng Bernoulli's equation is lost P1 squared over 2G plus P over gamma is equals to C2 plus V2 squared over 2G plus P2 over gamma plus head loss. Since hindi naman sinabi yung head loss, or sinabi dyan na i-neglect daw natin yung mga frictional effects, therefore, head loss is equals to 0. Since walang elevation, 0 na rin ito. Okay, so therefore, ang ating working formula for number 6 is okay, B1 squared over 2G plus P1 over gamma is equals to P2 squared over 2G plus P2 over gamma. So, lagyan nyo ng ganito yung velocity. Ha? Kaya nilalagyan ko siya ng ganyan kasi velocity is an vector quantity. So, vector, ibig sabihin, meron siyang direction. Kaya laging may ganyan yung velocity. Okay, so i-check natin yung ating given kung pwede ba siyang i-direct sa velocity 1, kaya naman. Pressure 1, yan yung nawawala. Velocity 2, kaya din, no? In terms of diameter. Pressure 2, kaya din. Okay, so ang kukunin natin dito ay hindi pala kaya si velocity 2 kasi wala pala tayong volume flow rate. So ang gagamitin natin dito ay conservation of mass. Balik tayo dun sa unang discussion. So pag compressible fluids, mass 1s equals to mass 2. Or pwede siya in terms of volume flow rate. No? Volume flow rate 1s equals to volume flow rate. Okay, so isolve muna natin si velocity 2. Solving for D2. Okay, so Q1 is equals to Q2. Area 1 times velocity 1 is equals to area 2 times velocity 2. Or pwede natin gamitin yung simplified na formula na. Since circular naman yung pipe natin. So D1 squared D1 is equals to D2 squared D2. Is equals to D2 squared D2. Okay. So diameter natin at point 1 is 0.15. 0.15 squared. D1 natin ay 1.2 meters per second. Diameter natin at 0.2, 0.075. Then velocity 2, yan yung nawawala. So 0.15 squared times 1.2 divide 0.075 squared. So therefore, velocity 2 natin ay 4.8 meters per second. Okay, then check na natin kung kaya na. I think kaya naman na, no? Kaya na masolve si P1. So, saan ko nilalagay? Ito na lang, no? Sa baba. So, therefore, okay, B1 squared natin is 1.2 squared divide 2 times 9.81. Ang unit mo dito ay in terms of meters na, no? Meter squared per second squared over meter per second squared. So, meters na ang lalabas. Kahit hindi ko na isulat. Plus, P1 natin is yan yung nawawala. P1 over Gamma is 9.81. Unit mo dito, kilonewton per meter squared. Dito, kilonewton per cubic meters. So, unit mo dyan ay meters na lang din. Kahit hindi ko na isulat. Kasi unit-wise naman siya. Dito natin, yan yung na-solve natin. So, 4.8. 4.8 divide 2 times 9.81 plus dito natin 101.325 divide gamma, which is 9.81. Okay? So, maganda, i-simplify nyo na sa calculator nyo. Pagsamahin nyo yung velocity and also yung pressure. Okay. So, magiging 1.2 squared over 2 times 9.81. So, yung 1.2 i-minus mo na sa 4.8 squared. Same lang naman siya ng denominator. Then plus alpha x over 9.81. So yung alpha x, yung P1, i-minus mo ng 101.325. Then equate mo sa 0 para mabilis. So shift solve. Okay. Then pressure natin is 112.125 kilopascal absolute. Okay. So, nasa choices natin, ang kailangan ay gauge pressure. So, minus pa natin ng 101.325. Minus 101.325. Therefore, 325. Kaya mo na. 10.8 kilopascal each. So, yan yung sagot natin sa number 6. So, letter D. Okay. So, next, number 7. Number 7, ano to? Under siya ng difficult problem na sa board exam. Okay. So, matinding analyzation ang kailangan dito. So, inyo kayo na ang magsagot. Hindi ko ata ito kaya. Okay. Number 7. So, number 7, a 90-degree reducing elbows is in vertical plane and water flow fluid. What is the horizontal force required to hold the reducer elbow in a stationary position? So, ito daw yung elbow natin. So, sa exit, meron tayong 30 cm diameter. Sa entrance, meron tayong 40 cm diameter. Then, exit condition, pressure natin is 200 kilopascal. Velocity natin at inlet is 15 meters per second. Ang tinatanong dito is the horizontal force required to hold the reducer elbow in a stationary position. Okay? So yung force na kailangan or yung force na pang-counter natin para maging stationary position yung ating elbow. So let's say meron tayong force dito, no? Meron tayong force ng fluid. Tapos kapag meron kang force ng fluid dyan, meron kang force ng counter. Okay, so yung force counter yung hinahanap. Para maging ano siya. Stationary. Okay. So based dyan sa ating diagram, ano? Force counter is equals to force ng ating fluid. Okay? So para makuha mo yung force ng ating fluid, kailangan mo i-consider yung pressure ng fluid. So force in terms of pressure. And also, since elbows yan, kailangan mo i-consider yung impulse. Okay? Impulse force. Yan. Okay. So, naturo ba tong impulse sa inyo? Alam ko, sa dynamics yan tinuturo. Formula ng impulse, pressure muna tayo. Formula ng pressure, terms of force, is yung ano lang, no? F over A. Tama? So, force in terms of pressure is equals to pressure times area. In terms of impulse naman, force in terms of impulse, formula natin since water to, no? Since hydraulics to, formula natin is density times area times velocity. So, ano yung impulse na i-consider natin? Siyempre, dun sa exit. No? Diyan may impulse. So, area 2 times velocity. Okay. Therefore, force counter is equals to pressure times area plus density times area at 2, velocity at 2. So, kaya na bang isolve? Check natin. So, pressure mo na i-consider is yung pressure mo rin sa exit. Kasi nandyan yung lalabas yung fluid eh. So, P2 times area 2. Okay. Yan. So, P2, okay naman. Given naman siya. Area, gagamitin mo yung 30 cm na diameter at exit. So, okay din. Kaya ma-solve yan. Density natin, since water ang ating fluid, nabi naman dyan sa problem water, kaya yung density. Area 2, kaya din. Velocity 2 ang wala. Resolve muna natin si velocity 2. Okay. So, solving for velocity 2, gagamit ulit tayo ng conservation of energy. So, nasa na ba yun? Ito na lang, no? Q1S equals to Q2. Solving for velocity 2, we have Q1 S equals to Q2, area 1, tama, velocity 1 is equals to area 2 times velocity 2. Or kahit hindi na natin ilagay yung pi over 4, no? So, magiging T1 squared P1 is equals to T2 squared P2. So, T1 natin, ito no, 40 cm. So, 40 squared cm squared. V1 natin ay 15 meters per second. Diameter 2 is 30. 30 squared cm squared, then velocity. Okay, cancellation of units, cancel si cm. So 40 squared times 15 divide 30 squared. Okay. So therefore, velocity 2 natin ay ilan ba? 26.67 meters per second. Okay na si velocity 2, masasolve na natin yung force counter. Therefore, Fc is equals to, pressure natin is 200 kilopascal. So 200 kilopascal. So kilonewton per meter square. Area natin at 2 is pi over 4 times 30, no? Kasi 30 yung ating diameter. Pi over 4. So, i-divide na natin by 100 para in terms of meter squared na siya. Okay? Para ang lalabas na unit natin ay kilonewton na. Okay. Then plus density of water is 1,000 kilogram per cubic meters. Area natin, area 2. So same lang din, no? Pi over 4. 30 over 100 squared, meter squared. Then velocity 2 natin ay nakuha natin, which is 26.67. 26.67 meters per second. So, ang unit natin dito ay in terms of Newton. So, i-divide natin pa ng 1,000. 1 kilonewton is 1,000 Newton. Cancellation of units, kilogram meters per second squared. Ay, teka. Ano ba? Dapat naka-squared yung ating velocity. Yan. Okay. Squared meter squared per second squared. Okay. So, cancellation of units, kilogram, so meter per second squared is Newton. Cancel C, cubic meters. Yan, tama, kilonewton. Then input na natin. So 200 times pi. Labas na natin pi over 4, no? Since common factor naman. Tapos cancel na natin si 1,000. So pi over 4 times 3 over 10 squared. Okay. So 200 plus 26.67 squared. Okay. So, ang number ko ito? Number 7. So 64.415. Unit natin dito ay kilonewton. Check natin kung nasa choices. Yung 64. Number 7, 64.4. So letter C. Okay, ganyan mag-solve, no? Kapag mga forces, summation of forces. Yeah. Number 8 na tayo. May tanong ba sa number 7? Kaya naman sagutan siguro yun. Number 8, the potential flow velocity distribution of atmospheric air around the cylinder is P is equals to 2 P's of infinity sine theta. The free stream velocity is 30 meters per second. The air density is approximately 1.202 kilogram per cubic meter. What is the most nearly pressure at point A? So ito yung ating diagram, no? So at point 1 or point infinity, say point infinity, then yung at first point, pupunta dito siya sa ating point A, yung ating second point. Okay? So first point, point infinity. Second point natin, point A. Okay. So, kunin natin yung given sa number 8. So at point infinity, meron tayong given na 30 meters per second. So V of infinity is equal to 30 meters per second. Then, atmospheric daw yung ating initial condition, no? So, P of infinity is equals to 101.325. So, at point 2, yung V daw natin, VA is equals to P, 2V infinity of sine theta. Then also meron tayong density of 1.202 kilogram per cubic meters. Ang tinatanong dito is the pressure at point A. So PA ang hinahanap. Okay. Solution. So first thing na gagawin natin, solve muna natin tong velocity at A since in terms of equation siya. So velocity at A is equals to 2 B of infinity sine theta. Yung theta natin at exit, no? Theta natin at exit is 90 degree. Therefore, velocity at A is equals to 2. Yung ating V of infinity is 30 meters per second sine 90 degrees. So 60 sine 90. Okay, therefore velocity at A is 60 meters per second. Okay, so nakuha mo na si velocity, meron ka ng pressure. So masasolve mo si PI by using Bernoulli's equation. Okay, so point 1 muna tayo. So V of infinity squared over 2G plus P of infinity over gamma ng air. Kasi air yung ating dito. Ating medium. Plus C of infinity is equals to at point 2 velocity at A squared divided by 2G plus P at A over gamma ng air din plus C at A plus head loss. Okay. So wala tayong elevation. Then wala tayong head loss. So in terms of velocity and pressure lang tong number 8. So V's of infinity, so given naman siya. V's of infinity, given naman. VA, yan yung nakuha natin, 60 meters per second. So one equation, one unknown, itong ating equation. So masasolve natin siya. So V of infinity is 30 squared meters squared per second squared divided by 2 times 9.81 meters per second squared. V of infinity is atmospheric 101.325 kilonewton per meter squared divided by gamma ng air. So gagamitin mo dito yung density. Okay. So gamma ng air is density 1.202 times gravity, which is 9.81. Ang lalabas mo dito na unit ay Newton per cubic meters. So convert mo siya into kilonewton. So i-divide mo siya ng 1,000 Newton per kilonewton. Okay. 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 So PA natin is 60. So 60 squared meters squared per second squared, 2 times 9.81 meters per second squared. Plus PA, yan yung hinahanap, over gamma ng air, same lang din, 1.202, 9.81, okay, Newton per cubic meters divided by 1,000 Newton per 1 kilonewton. So actually, kahit lagay natin to in terms of kPa, kasi makakancel naman to. Newton meter squared, Newton per cubic meter, kilonewton, tsaka Newton. Ito naman, makakancel lang din. So, kilopascal yung unit na lalabas. Okay, so input natin sa calculator. Pagsamahin natin lahat ng may same denominator para malesen yung i-input natin. So, 30 squared over 2 times 9.81. 30 squared minus 60 squared. Then, plus 101.325 minus PA alpha x over 1.202, 9.81 divided by 1,000 is equals to 0. Shift solve. Makuha natin yung pressure. Pressure is equals to 99.7. 99.70 kilopascal. Check natin sa choices. So letter D. Diba? Ang dali lang pag mga Bernoulli's equation. Okay, so next item tayo. Next item under differential ng Bernoulli's. So given the following venturimeter and the two pressure shown, calculate the mass flow rate of water in a circular pipe. Okay. So kunin muna natin si given. So at point 1, yan yung PA and TA. Point 2 natin, PB and TB. Okay. So ang hinahanap dito ay mass flow rate of water. So M dot. So required natin is mass flow rate. Solution na agad. Okay. Under siya ng Bernoulli's equation, formula natin is VA squared over 2G plus PA over gamma. Since nasa 0.1 pa lang tayo. No? Plus C is equals to 0.2. So PV squared over 2G plus PB over gamma plus CP or CA CB. Yeah. Since walang elevation, cancel ulit natin. Okay. So velocity. Teka, ha? So wala tayong velocity, no? So si velocity makukuha natin yan kapag may volume flow rate. Kaso wala tayong volume flow rate. So wala na. Skip na to. Charot na. PA meron. PB, velocity, wala din. So, mag-aano tayo dito ng equation. Parang, ayusin natin yung equation. Formula natin ng velocity. Velocity is equal to 4Q over pi t squared, di ba? Tama. So, kapag VA, formula natin ng velocity ay 4Q over pi TA squared. Sa point 2, PB, formula ng velocity is 4Q over pi TB squared. Okay. So, i-write natin siya doon sa ating equation. So, BA squared. So 4Q over pi dA squared, then squared over 2G plus PA over gamma is equals to BV natin 4Q over pi dB squared over 2G. Okay. Plus PB over gamma squared to, no? Yan. So, bawal kang mag-cancellation ng unit dyan, ha? Kasi naka-operation ka. So, try natin kung kaya ng mag-direct sub ng given. Okay. So, wala tayong Q, pero meron tayong diameter. So, isa yung nawawala sa first term. Meron tayong PA. So, same lang din dito, no? Q lang din ang nawawala. Meron tayong PB. So, kayang ma-solve C, volume flow rate. Okay. So, therefore, 4Q over pi, PA natin is 0.3, 0.3 squared. Then, squared divided by 2 times 9.81. So, unit-wise naman to, kahit hindi mo na isulat ang units. No? Plus, pressure at A is 200 over gamma S. Ano ba ang fluid dito? Water, no? So, gamma ng water, 9.81 is equals to 4Q over pi diameter at B is 0.1, 0.1 squared over 2 times 9.81, then plus pressure at P is 150 over 9.81. So, makukuha natin si volume flow rate. So, pagsamahin natin yung may same denominator. So, 4 alpha x over pi 0.3 squared, then squared, minus 4q, 4 alpha x over pi times 0.1 squared plus 200 minus 150 divide 9.81 is equals to 0. Okay. Right. Mali ata equation. Walang over 2 times 9.81. Ulit. So 4 alpha x over pi 0.3 squared minus 4 alpha x over pi 0.1 squared over 2 times 9.81. Ayun. Then plus 200 minus 150 over 9.81. So shift solve. Okay. So ang Q natin is 0.3 0.079. Unit natin dito ay cubic meters per second. Okay, ano bang tanong dito? Mass flow rate ang tinatanong. So, formula ng mass flow rate is equals to density ng water times volume flow rate. Density ng water is 1,000 kilogram per cubic meters. Volume flow rate is 0.079 cubic meters per second. So, kilogram per second ang lalabas. So, times 1,000. So, 79.029 kilogram per second. Check natin anong letter? 79. So, letter T. Okay. Okay. Number 10 tayo. Nakasabay pa ba? Kaya naman ano. Okay. Number 10, a pitot tube is used to measure the flow of incompressible fluid where density is 926 kilogram per cubic meter. If the velocity is measured as 2 meters per second and the stagnation pressure is 14.1 kilopascal, what is the static pressure of fluid where the measurement is taken? So for number 10, meron daw tayong pitot tube. Ano? Yan. So, yeah. So let's say ito yung ating pitot tube. Then, so meron tayong density of 926 kilogram per cubic meter. So may papasok dito na velocity P1, pressure 1, and also meron tayong density of 926 kilogram per cubic meters. Okay. Then meron tayong point at stagnation. So let's say nandito yung PS and ating velocity at stagnation. Okay, so B1 natin is 2 meters per second. Okay. Stagnation pressure is 14.1. Ano pa ba ang given? Wala na. What is the static pressure of fluid where the measurement is taken? So, ang record dito, what is the static pressure? So, P1 ang hinahanap. Okay, solution. So, Bernoulli's equation lang din to kasi flow lang din naman ito. Ayan. So, since hindi sinabi yung stagnation velocity, considered natin siya as 0. Not stated. Okay, ang ating working formula ay yung papasok muna, V1 squared over 2G plus P1 over gamma. Wala namang elevation, ano? So, huwag na natin isulat. Is equals to pressure at stagnation over gamma plus velocity at stagnation squared over 2G. Since PS natin is equals to 0, 0 na yan. Okay. Okay. Thank you. So B1 natin is ilan ba? 2 meters per second, no? So 2 squared meters squared per second squared over 2 times 9.81 meters per second. T1 natin, yan yung hinahanap. Gamma natin ay gamma. Ano bang fluid natin? Walang sinabi, no? So, pag walang sinabi, gagamitin natin yung density. So, 926 density times gravity, 926 times 9.81. So, ang unit mo dito ay in terms of Newton, ano? Newton per cubic meters, divide mo ng 1,000. Parang kilonewton per cubic meter. Yan. Is equals to TS, given pala, 14.1 kilonewton per meter squared or kPa na lang. Same lang din, 926, 9.81 over 1,000. So yan, okay na yan. Palag-palag na. 2 squared over 2 times 9.81 plus alpha x minus 14.1 over 926, 9.81 divide 1,000 is equals to 0. Okay, so 12.248. 12.248 kilopascal. Check natin. Anong letter? Letter C. Okay, so number 11. So number 11, next topic na to. Kasi may nozzles na, tsaka may mga jet na. No? Punta tayo sa next topic. Kaya pa ba? Okay. So hydrodynamics tayo. Ito na ang medyo malalim. Ano? So hydrodynamics. So ito ginagamit, ang application ng hydrodynamics sa atin ay sa pipe. Okay? So pipe bend force analysis. So let's say ito yung pipe natin. Ano? So meron tayong point 1 and meron tayong point 2. At point 1 meron tayong velocity. Point 2 yung exit velocity. So dito sa pipe natin, no, may force dyan na nag-act. Force, ito yung resultant force. Mayroong force at yung vertical, then force at horizontal. Yung force na nag-act dito is the force exerted by the bend on the fluid. Okay? So pag tinanong dito is force at horizontal or Fx, yung force impulse ang gagamitin mo. No? So summation of Fx. Pag y, summation of Fy. Kapag F, resultant, square root of Fx squared plus Fy squared. So to elaborate yung formula, so ito yung formula na gagamitin natin. Okay? So formula ng force impulse is density times volume flow rate times V1, V2 minus V1. Okay. So saan nanggaling yan? So nanggaling yan sa formula ng momentum where impulse is equals to momentum. Okay? Formula ng impulse is mass times delta T. Okay? Where yung force is mass over time times P2 minus P1. So itong time, dinivide mo lang dito, tapos yung delta B, inano mo lang, and expand mo lang. Yung M mo, pwede mo siyang i-write in terms of yung mass flow rate, no? Pwede mo siyang i-write as density times volume flow rate. For volume flow rate, ang simple natin ay Q. Kaya dyan nakuha yung formula ng impulse. Mass times delta P divided by time. Okay? So density times Q, P2 minus P1. So, kapag i-consider mo yung x, nasan yung x natin? Andito siya, no? Banda. Pa-horizontal. Okay, formula natin is density times Q, P2 cosine alpha minus P1. Kapag Y naman, sine. Okay? Density times Q, quantity V2 sine alpha. Okay. So, kapag i-consider mo yung pressure, summation ng f of x natin is negative fx plus P1A1 minus P2A2 cosine alpha. Kapag summation of Fy na kino-consider yung pressure, formula natin is Fy minus P2A2 sine alpha. So, ito, try natin i-apply the next example natin. Okay, number 11. Okay. So, number 11, if the velocity of flow in a 75 millimeter diameter fire hose is 0.5 meters per second, ano na natin yung given para mabilis. So, 0.5 meters per second, yan yung ating P1. Diameter 1 natin is 75 millimeters. Okay. What is the velocity in a 25 millimeter diameter jet? So, TJ na lang, no? Or D2. D2 na lang yung jet. Sige, DJ na lang. 25 mm. Ang hinahanap dito is the velocity. Velocity and also yung power. Velocity ng ating jet and power ng ating jet. Okay? Okay, so solution. So pag tinatanong power ng jet, no, formula natin ay 1/2 times density times area ng jet times velocity raised to 3. So medyo similar siya sa pagkuha ng power ng sa wind turbine. Okay? So yan. So ito yung ating working equation for the power. Okay. So meron tayong density. Since water naman yan, no? 1,000. Area natin, pwedeng makuha sa diameter. So pi over 4d squared. Ang wala tayo is yung velocity ng ating jet. So, para makuha si velocity ng jet, nagamit tayo ng conservation of mass. A1, B1 is equals to area ng jet, velocity ng jet. Or B1 squared, B1 is equals to DJ squared DJ. Okay, so kompleto naman yung tatlo. Makukuha natin si velocity ng ating jet. Then direct sub na dun sa power. Then yun na pala yan, no? Number 11. Velocity and power. Sakto lang. Okay, so D1 squared natin is 75 mm. So 75, wag na natin i-convert, no? Unit-wise naman, no? Squared. Mm squared. D1 natin is ilan ba? 0.5 meters per second is equals to 25 mm times velocity ng ating jet. Cancel si mm squared. Yan. So unit natin ay meters per second. 75 squared times 0.5 divided by 25 squared. So 4.5 meters per second. 4.5 meters per second. So yan ay sagot natin Yan yung isang tanong, di ba? Check natin. Sino bang 4.5? So letter A na agad yan. No? Pero check pa rin natin kung 22.36 yung lalabas. Solving for power. Power ng jet is equals to 1/2 times density times area ng jet, velocity ng jet raised to 3. So 1/2, density natin 1,000 kilogram per cubic meters. Area natin is pi over 4. VJ is 25. Divide natin ng 1,000 para in terms of meters na siya. Squared, meter squared. Velocity ng jet natin ay 4.5 raised to 3 meter cube per second. Cancellation of units. Kilo, gawin na natin ano no. Ay, hindi, wag na. Kilogram. Cancel na natin to. Meters per second squared. Kunin natin yung dalawa, no? Isa na lang. Kilogram meters per second squared is Newton. Tapos may matitira pang isang meter, may matitira pang isang second. So, Newton meter per second or watts ang ating magiging unit dyan. Okay. Therefore, power ng ating jet is equals to, cancel na natin to, no? Ay, hindi, naka-squared pala. Huwag pala. So, 1/2 times 1,000 pi over 4, 25 over 1,000 squared, 4.5 raised to 3. Okay, so 22.36 nga watts. So tama yung sagot, no? Letter A. Ayun, 22.36. Okay. Number 12. Ayun, may picture na naman. Putain na. Okay, number 12 tayo. Pag may mga figure, no, nakaka-appreciate is allergic ako sa mga picture. Okay, so number 12, water flowing in the velocity of V1 in a pipe is turned to flow in the x direction as shown. What is the relation between the y component of the force of the water jet acting on the inclined plate and the inclination angle? So force, ang hinahanap is force of the water jet acting on the inclined plate and the inclination angle. So force acting on theta. Okay. Paano ba ito i-visualize? So ito yung ating ano no, diagram. I-rewrite ko pa ba? So meron tayong theta. Kasi dito ko nalang isulat. Meron tayong x component. Meron tayong y component. Okay. Then meron tayong force dito. So sa force, meron ditong theta ano. Okay. So ang tinatanong dito is the force acting on theta. So kung may F ka dyan, meron kang velocity vertical. Vy. Yan. Tapos meron kang dx dito. Or let's say d1. Kasi yan yung papasok eh. Okay. Okay. So, ang hinahanap dito is force on theta. Okay, solve na natin. Wala namang given na ano, no? Wala namang mga given. So, equation yung isa-solve natin. So, formula natin, again, formula ng impulse is equals to mass times velocity. So, yung velocity na i-consider natin is yung velocity at y. Kasi yan yung mag-a-act doon sa ating theta. Okay? What is the formula of mass? Formula of mass is density times area ng ating jet. So, AJ, BJ. Yeah. Then, dy natin, since may theta, pwede natin siyang i-write as sine, ano? Diniscuss ko yung kanina, di ba? Yan. Kapag y, sine theta. Tama? So, BJ, sine theta. Okay? Common terms, labas natin, BJ, multiply natin. Therefore, Fy is equals to density, area ng jet, velocity ng jet squared, sine theta. So, yan yung sagot sa number 12. Anong letter ba to? Letter D. Yan, dali lang pala. Okay, number 13. Oh, just ko, mag-figure na naman. So, number 13, the vein shown reflects a jet velocity, V-jet density, and cross-sectional area in jet through an angle 40 degrees. Calculate the horizontal force on the vein. So, ang hinahanap dito is FH. Okay? So, kapag FH, di ba, binigay ko na yung formula kanina. Kapag H, yan yung X natin. Ano? So, in terms of cosine, pag dinerive natin siya, let's say FH is equals to FH is equals to density times area ng jet times velocity ng jet multiplied by PJ minus PJ cosine. Angle natin 40. Ito siya. Since velocity ng jet yung hinahanap, so yung V2 mo is equals to V1. Okay. Then, labas natin si BJ. Density times area ng jet. Velocity ng jet squared 1 minus cosine 40 degree. So, letter and number 13. The next, number 14. Number 14, a uniform area jet travels to 600 feet per second and a 100 cubic feet per second. What is the horizontal force acts on the water jet if undergoes a 180 degree turn? So let's say meron tayong jet ano. Yan. Yan. Kasi ito yung jet natin. May tatalsik dyan. So, nandito yung B1. Lock na lang. Meron tayong B1 dito. Since magto-turn siya na 180 degree, doon mapupunta si B2 mo. Bakit siya nag-turn ng 180? Kasi meron kang ano dito, parang pader. Doon mo patatamain yung jet mo. Yan. Ayan yung itsura niya. Okay? So, kunin natin yung given. So, meron tayong volume flow rate of 600 feet per second. Volume flow rate. Velocity pala to. Velocity ng jet. Yung 100 yung cubic feet per second. Yan yung ating volume flow rate. Then, theta natin is 180 degrees. Ang hinahanap is what is the horizontal force? So, FH. Okay. So, horizontal force natin, anong formula? Yung na-derive natin kanina. Ito, no? Density times area Bj squared 1 minus cosine theta. Density, area ng jet, velocity ng jet squared 1 minus cosine theta. Density natin, anong unit to? English, ano? 62.4 pound mass per cubic feet. Area natin is yung area pwede natin siyang i-rewrite as nga lang. Density, area times velocity. Q, no? Qj. 1 minus cosine theta. Serve natin as equation number 1. Ako na lang ilagay sa baba. Okay. Therefore, horizontal force is equals to density 62.4 pound mass per cubic feet. Okay. Q natin is 100 cubic feet per second. Then 1 minus cosine 180. Tama ba yung formula ko? Q is equals to area times velocity. May matitira pa palang velocity dito. Kasi isa lang naman ang kinuha mo. Okay. So multiply ba natin by velocity? Velocity natin is tama ba? Tama. 600 feet per second. Yan. Ngayon kasi ito isa-solve eh. Over, divide natin sa GC, 32.2 pound mass feet per pound force second squared. Okay, cancellation of units. So, cubic feet, pound mass, second squared, cancel, then feet. Ang lalabas yan is pound force. $62.4, 100, 1 minus cosine 180 times 600 over 32.2. Laki naman. Teka ha. Okay. Times 10 raised to 5. So, eng natin. 2.325. Yun, letter A. Okay. 2.325 times 10 raised to positive 5. Pound force. Okay. So, yun na. Ang number 2. 14. So, next item. 15. Just ko, may picture na naman. Okay, so number 15, water is flowing at 50 meters per second through a 15 cm diameter pipe. The pipe makes 90-degree turn. What is the reaction on the water in the C direction at the bend? Okay, so meron daw tayong tubig, ano? So, initial condition, D1 natin, saan dito? So, nagfo-flow siya at 50 meters per second. Then, after niya mag-flow dyan, 90-degree turn daw siya. So, from here, nagganan siya. Kulay red ko na lang. From this pipe, nag-90-degree turn siya. Okay. So, therefore, yung diameter pala nito, D1, is 15 cm. Theta natin is 90 degree. Yan. So what is the reaction on the water in the C direction? Okay. So FC ang hinahanap. Okay. So FC is equals to density times volume flow rate, velocity 2 at C minus velocity 1 at C. Okay, so yan yung ating general formula. So since yung velocity 1 mo sa C dumiretso, no? Sa point C. Therefore, yung iyong velocity at C ay same no B1. BC is equals to B1, 50 meters per second. Okay? Then at point 2, ito ko na lang isulat. FC. Okay. So velocity at C is 50 meters per second equal siya sa velocity at 1. Then yung velocity at 2 mo, nung tumama siya dito, no, P2 is equals to 0 meters per second. Okay. Okay, so check natin kung kayang isolve. So yung Q, pwede mo siyang i-write as area times velocity. So FC is equals to density times area ng jet times velocity ng jet P2C minus P1C. Okay. So si area, density, kaya kasi water naman siya. Area, may diameter ka, which is 15. Velocity ng jet, yan yung velocity 1 mo. Okay, 50 meters per second. Or equal din siya sa velocity ng C. Kaya din yan. B2, 0, B1. Okay, direct sub lang po. Therefore, force at C is equals to 1,000 kilogram per cubic meters. Area mo is pi over 4. D mo is 15 over 100 squared meters squared. Velocity ng jet mo, yung velocity at C, so 50 meters per second. Velocity 2 is 0. Velocity 1 is 50 meters per second. Okay. Cancellation of units. So kilogram meter per second squared is Newton. Then cancel na to. So Newton ang magiging unit natin dito. So 1,000 pi over 4, 15 over 100 squared, 50 times negative 50. Okay. Then i-divide natin ng 1,000 since choices natin is in terms of kilonewton. Minus 1,000. Minus. Shit. Ano yun? Bakit minus 1,000? Divide 1,000 dapat. Divide 1,000. 44.18. Therefore, FC, negative 44.18 kilonewton. So, letter A yung sagot natin. So, bakit negative ang sagot? Kasi, yung talsik niya, yung talsik ng water sa jet ay patalikod. Tama? Negative kasi sinulat din. Patalikod yung ng tubig. Yan. Tama? So, yan. So, letter A ang sagot. So, negative 44.18. Okay. So, number 16. Okay. Tapos na tayo dyan sa hydrodynamics. Ayan. Nakakapusin. Next topic na tayo. Orifice naman tayo. Orifice is a small opening from which the liquid flows. Formula natin, volume flow rate at orifice is area prime times velocity prime. Area prime mo, yan yung actual mo na area. I-multiply mo yan sa CC. Okay? CC is coefficient of contraction. So kapag walang given na CC, automatic area actual is equals to area ideal. Okay? Pag walang given na CC, automatic 1 yan. Okay? Velocity prime or actual velocity is equals to CV times velocity ideal. Okay? CB is coefficient of velocity. Okay? Where kalimitang area natin dito is pi over 4 d squared. Velocity naman is square root of 2gh. So via derivation, pwede mong i-rewrite yung CB times CV as CD or coefficient of discharge. So CD is CB times CC. So therefore, Q prime, volume flow rate actual is equals to CD, coefficient of discharge times area times velocity. Okay? Then Mach number, na-discuss ko na to, no? Ito yung ratio ng speed of body to the speed of sound. So, ito yung pinaka specific when it comes to Mach number. Yung binigay ko sa nacelles, 3 lang, no? Pero pag specific yung tinatanong ito. Less than 0.8 subsonic, 0.8 greater than 0.8, less than 1.3 transonic, kapag equal to 1 yung Mach number, sonic. Kapag greater than 1.3 but less than 5, supersonic. Greater than 5 but less than 10, hypersonic. Greater than 10 but less than 25, high supersonic. Then yung Mach number na greater than 25, yan na yung re-entry speed na tinatawag. Okay? So sa elements, naka-invento ng, or yung Mach number pinangalan after Austrian physicist Ernst Mach. Velocity of sound, na-discuss ko na rin to, no? Pag sa gas, square root of ART. Okay? For liquid naman, hindi ko ata ito na-discuss dati, no? So kapag velocity ng sound in terms of liquid, formula natin is square root of E over density, or Wolff modulus of elasticity divided by the density. So, try natin sagutan number 16. Number 16, two tubes are mounted to the roof of a car. One tube points to the point of the car while the other points to the rear. The tubes are connected to a manometer filled with a fluid of specific gravity 0.62. When the height difference is 3 inches, what is the car's speed? Okay, so sa number 16, kunin natin yung given. So meron tayong specific gravity nung ating fluid. Okay? So fluid natin ay liquid. Okay? So SG ng ating fluid is 0.62. Then height difference, ibig sabihin yan yung ating height ng liquid. So 3 inch. Ang hinahanap is yung speed ng car. Velocity ng car. Okay. So velocity ng car natin, yan, equal na yan sa velocity ng air natin. Kasi dalawa lang naman ang ating fluid dyan. Air tsaka liquid. Okay. So since yung tube ng ating yung dalawang tube na to, 0.1 and 0.2, nandun siya nakamount sa roof ng car. Therefore, yung speed ng air, yan na yung consider natin as speed ng ating car. Yan yung hinahanap. Okay? Okay, so solution. So para ma-solve natin si velocity ng air, i-write natin siya in terms of dun sa Bernoulli's equation. Okay? Velocity ng air squared over 2g is equals to elevation head ng ating air. Serve natin siya as equation number 1. So, elevation head ng ating air, wala. Yan yung H ng air. Okay, sa ating fans and blowers. Velocity ng car, wala din. So, isolve muna natin si H ng air or elevation ng ating air. So, masasolve natin yan by equating air doon sa water. So, gamma ng air, head ng air is equals to gamma ng water or gamma ng liquid, head ng liquid. Okay? Given naman si head ng liquid tsaka si SG, makuha natin to. Gamma ng air, so makukuha natin si C. Okay? So gamma ng air is 0.075 pound force per cubic feet. H ng air, yan yung ating C. Gamma ng liquid is 0.62. 62.4 pound force per cubic feet. H ng liquid natin ay yan, 3 inch. So 3 over 12 in terms of feet na siya. So unit natin dito ay in terms of feet. Okay. 0.62, 62.4, 3 over 12 divided by 0.075. So therefore, C ng ating air, elevation ng air is ilan to? 128.96 feet. Okay. So, nakuha na natin sa elevation. Ang kukuha na natin si car speed or velocity ng air. So, velocity ng car or velocity ng air over 2G is equals to C ng ating air. Velocity ng air squared to squared over 2 times 9.81. Ay, English ba to? English pala. 32.2. 32.2 feet per second squared is equals to 128.96 feet. So, ang unit mo dito is feet squared per second squared. Square root mo magiging feet per second. Therefore, velocity ng car is equals to velocity ng air is equals to square root of 128.96 over 2 times 32.2. Ay, bakit ba dinivide? Multiply pala. 128.96 to 32.2. Yan, 91.132. Unit natin dito is feet per second. So, check natin. Ako, naka miles per hour pala to. So, convert muna natin. Therefore, velocity ng car is equals to 91.132 feet per second. Convert na muna natin yung second to hour. So, 36 second, 1 hour. Yung feet sa mile, 1 mile is yung statute nung gagamitin natin, 5 to 80 feet. Yan. So, miles per hour na lang. Okay. Times 36 divide 5 to 80. So, 62.135 miles per hour. Okay. So, letter C, 62 miles per hour. Okay. So, number 17. What is the actual volumetric flow rate for the discharge of the tank shown? The coefficient of contraction for the orifice is 0.61 and the coefficient of the velocity is 0.98. Okay, kunin muna natin si given. Coefficient of contraction, 0.61. Yan yung ating CC. Coefficient of velocity, yan yung ating CV, 0.98. 8 feet, yan yung ating height. Height nung water. Yan, 8 feet. Then, meron tayong area ideal of 0.5 feet squared. Nahanap is what is the actual volumetric flow rate? So, Q prime ang hinahanap. Okay? So, since meron tayong coefficient of contraction and velocity, sa orifice tayo mag-base na formula. Ito. So, Q prime is A prime times B prime. So, CC times CB times area times velocity. So, CC, CV, area ideal, times velocity. Ideal. Wala pala tayong velocity. So, si velocity, pwede mo siyang i-write as square root of 2gh. So, therefore, Q prime is cc times cv times area times square root of 2gh since height ang given natin. Okay? Therefore, Q prime is equals to cc 0.61, cv 0.98, area natin 0.5, square root of 2 times 32.2 feet per second squared times 8 feet. Okay? So, cubic feet per second ang lalabas na unit. 0.61, 0.98, 0.5 square root of 2, 32.2 times 8. Okay, so 6.7. 784 cubic feet per second. Check natin. 6.78, so letter B. Okay. Number 18. So what is the velocity of sound in 150 150 degree Fahrenheit water if its density is 61.2 pound mass per cubic feet and the bulk modulus of elasticity is 328,000 psi. So velocity of sound ng water. No, formula natin is square root of E over density. So kahit hindi ko na isulat yung given, ano, square root of E over density. Okay. So, E natin, 328,000 pound force per inch squared. Okay. Convert natin, 144 inch squared per feet squared. Divided by 61.2 pound mass per cubic feet. So, hindi mo makakancel yung pound mass sa pound force, ano? Check na natin. Density is equals to ano naman? Density is equals to gamma na. Kaya naman pala. Cancel si inch squared. Ito, magiging isa. So, hindi mo mapabalabas si feet squared per second squared. Wala kang per second. So, gagamit ka ng GC, gravitational constant. Okay? So, lagay natin sa taas. 32.2 pound mass feet per pound force second squared. Yan. So, kailangan mo yung GC para mapalabas mo si second squared. So, pound force, cancel siya. Pound mass, cancel. So, feet, tataas to. So, magiging feet squared per second squared. Okay. Therefore, velocity ng sound is square root of 328, 144, 32.2 over 61.2. 4985.06 feet per second. Okay, so letter A yung sagot natin sa 18. Okay, so number 19, airflow past a 2-inch diameter sphere at 100 feet per second. What is the drag force experienced by the sphere given that it has a coefficient of drag? Bakit drag? Dapat. Yan. of 0.5 and that the density of the air is 0.00234 slug per cubic feet. So number 19, under na siya ng drag force. No? So discuss ko lang ng mabilis ang drag force. So drag force, sometimes called air resistance, a type of friction or fluid resistance, is a force acting opposite to the relative motion of any object moving with respect to the surrounding fluid. Formula natin sa drag force is 1/2 times drag coefficient times density times area perpendicular. Bakit perpendicular? Kasi nga, ito yung force acting opposite the relative motion of on any object moving. Okay? Kaya, dapat yung i-consider mo dito is yung area perpendicular doon sa flow ng fluid times mean velocity squared. Okay, so try natin sa number 19. Okay. Kunin muna natin yung keypad. Okay. So, meron tayong sphere, diameter of 2 inch. Meron tayong mean velocity of 100 feet per second. Coefficient of drag, so CD, 0.5. Density of air is 0.00234 slug per cubic feet. So, ang hinahanap dito is the drag force. So, F T. Okay. Okay. So, solution. Formula ng drag force is so 1/2 coefficient of drag times density times area perpendicular times mean velocity squared. CD meron naman, density given din, velocity given, kulang mo na lang is yung area. So i-drawing natin yung sphere para ma-determine natin kung ano yung area na perpendicular doon sa flow of air natin. So let's say ito yung sphere natin, Okay. So yan yung sphere. Tapos meron daw tayong flow ng hangin. Na nag-a-act doon sa ating sphere. Yan. Yan. Air. Okay? Okay. So yung area na perpendicular doon sa flow ng air ay circle din. Tama? So area ng circle lang kailangan natin. So therefore, formula natin ng drag force. So area perpendicular is equals to area ng circle, pi over 4 d squared. Okay? So therefore, drag force is equals to 1/2 times CD times density times pi over 4 d squared velocity squared. Okay, so direct sub na natin. So 1/2 CD natin 0.5, density is 0.00234. 0.00234 slug per cubic feet. Pi over 4. Diameter natin, given ba? Ayun, 2 inch. Convert na natin into feet. So 2 over 12 squared feet squared. velocity is 100 feet per second. Squared, feet squared per second squared. So take note nyo, no, since nakaslug yan, na-discuss ko na to ng first part eh. No? Slug, one slug feet per second squared is equals to 1 pound force. Okay. So slug feet per second squared is equals to 1 pound force. Then ito, may natirang isa plus 2, 3. So makakancel ko. So pound force yung unit natin dito. So 0.5 times 0.5, 0.00234, pi over 4, 2 over 12 squared times 100 squared. So therefore, drag force natin is 0.128 pound force. So letter C. Pag sinulat niyo yung problem sa notebook, sulat niyo rin yung choices, no? Para ma-look spam niyo din, no? Yung iba kasi hindi na sinusulat yung choices. Yung sagot na lang, hindi maluluk spam yan. Diba? Ano yan? Dito lang sa C pala. No? Sulat niyo rin choices para maluk spam niyo. Okay, last item tayo. Number, hindi, dalawa mo pala. No? Last two item. Okay, number 20, a circular cylinder 4 meter long and 3 meter inch diameter is in an airstream. The flow velocity is 5 meters per second perpendicular to the axis of the cylinder. Given that the coefficient of drag, Ct, on the cylinder is 1.3 and the density of air is 1.225 kilogram per cubic meters, what is the force on the cylinder? Okay, so number 20, under pa rin siya ng drag force. So, kunin muna natin yung given. Meron tayong cylinder, length of 4 meters, diameter of 3 meters. The flow velocity, so meron tayong velocity. So mean velocity of 5 meters per second perpendicular to the axis of the cylinder. Coefficient of drag is 1.3. Density is 1.225 kilogram per cubic meter. Sinahanap is the drag force. Okay. So, i-drawing natin yung cylinder para makita natin yung projected area or yung area parallel doon sa flow ng hangin. Okay? Formula ng drag force is 1/2 times CD times density area perpendicular P squared. Okay? So, let's say meron tayong dito, yung figure, cylinder. Let's say meron tayong cylinder. Pwede na ba yan? Yan. Okay na yan. Okay. Let's say meron tayong cylinder. So yung flow ng air natin, papunta dito. Okay. So ang ating projected area or yung area parallel, perpendicular dun sa flow ng air ay ito. Okay, so rectangle. Tama. So therefore, area perpendicular is equals to length times diameter. Okay. Length of 4 meters, meron tayong diameter of 3 meters. Okay. So, yeah, kaya na siyang masolve. Okay. So, drag force is equals to 1/2 times CV, 1.3. Density natin ay 1.225 kilogram per cubic meters. Area is length times diameter. So 4 times 3 meters squared. Velocity natin is 5 squared meters squared second squared. So ang lalabas mo dito ay Newton. So 1 kilonewton is 1,000 Newton. Kilogram meters per second squared. Kilogram meters per second squared is Newton. Then cancel tong cubic meters. Okay, kilonewton yung lalabas na unit dito. Okay, so 1/2 times 1.3, 1.225, 4 times 3, 5 squared. Okay, so 200, check nga, ay iba. Divide 1,000 pa pala. Divide 1,000. Okay. So 0.234 kilo Newton. Okay. So letter C. Then yung last item, madali lang ba to? Last item kayo na magsagot, no? Ano lang to? Mach number. What is the Mach number of the aircraft? Mach number is equals to velocity ng object divided by velocity ng sound. Velocity ng object, ito siya. Then velocity ng sound, 29 grams per mole, no? So air. At standard naman yung 29, no? So square root of K R. At 29 grams per mole, since standard yan, yung K mo, 1.4, R mo is 0.287. So direct sub lang yan, no? Kaya naman solve. Okay, so yeah, that will be all for fluid mechanics. Na-discuss ko na lahat ng nasa syllabus. So may tanong ba regarding on may tanong ba doon sa ating discussion for today? May question ba kayo? Questions or clarification? Ano, bakit ang tatahimik mo? Ano na? Ano magsasalita? Tayo na parang bulto dito magsasalita. May tanong ba or naintindihan naman?
Naintindihan naman po.
Wala naman.
Mahirap lang.
Naintindihan.
Ano mo pong tanong ko? Yan, very good. Naintindihan naman pala. So yung notebook natin, ano ba? Ay, nasabi ko na pala ito, no? So yun nga, hindi naman yan compulsory, no? So yung notebook, pakikompleto, ha? Kasi may nagpapasa ng mga INs. Kulang ng example, kulang ng formula. Binabasa ko yung notebook niyo. Kasi pag ako magbasa ng notebook. So pakikompleto, so kung pinasa niyo yan ng kulang, yung magiging grading system natin is quiz 1 plus quiz 2 divided by 2. Okay? So pag kompleto, quiz 1 plus quiz 2 plus notebook divide 3. So ganun, okay? So make sure na kompleto yung notebook niyo. Ipasa nyo na ng kompleto kasi baka mamaya ay ma-tsempuhan nyo, nag-check ako tapos na-record ko na agad. Eh wala na. Hindi na masasama sa computation. Okay? So pag nagpasa kayo, dapat kompleto na yung nakalagay dyan. Then, naka-share screen ba ako? Teka, mag-share screen. Then, ayun, mag-share screen ako. Then, merong alam ko nabanggit na ito ni Sir Minor, no? Merong university-wide simulated board exam. So, lahat nung naka-enroll ngayon ng ito. So, lahat ng naka-enroll ngayon ng INTEG, no, required kayo na mag-take ng simulated board exam. So, pinag-iisipan pa kung face-to-face yan or online. Yung unang propose namin ni Sir Minor is online since wala naman ng pasok yan eh. Wala naman ng grade, wala naman ng bearing yan sa grade eh. Pero sabi nung sa review center, baka daw pwedeng maging face-to-face. Pero kung face-to-face yan, 1 day lang. Kaso paano magiging board exam yun kung 1 day lang? So I hope online na lang to, no? Kasi wala naman bearing. Wala naman siyang bearing sa grade. So required lang kayo mag-take, no? So May 19, start tayo ng power plant. So ako yung magbabantay. Then May 20, so sa Pasig, si Sir Imperial, sa Bonnie Sir Minor. Unang iti-take nyo ay machine design, then sunod ay math. Okay, so 100 items yan ha, kasi 5 hours yan. Then, yun, yung finals natin, INTEG 2, INTEG 1 ay sa, kailan ba? Sa 6, ano, sabay nung kay Sir Minor. So sa power plant, since 3 hours yun, 12 to 3, 70 items. Yung math, 2 hours, 50 items. 5-0, math, 7-0 sa 5. Then as much as possible ha, paki-avoid ang magkopyahan sa finals. Kasi pag finals, dyan ako maraming nahuli na nagkokopyahan since marami nga yung naghahabol ng grades, no? Sa imbes na tumaas ang grade ay lalo pang nasisingko kasi nahuling magkopyahan. Okay? Then yung notebook, formula pala. Kailangan nyo ba ng formula sa fluid mechanics? No? So yung mga na-checkan ko na notebook, sabi ko kanila, paki-concise yung formula nyo. As much as possible, yung mga formula nyo, i-concise nyo para pag nag-review kayo, madali siyang i-memorize. Kasi parang yung dati sa akin, may separate lecture, mga concept nandun. May separate lecture ako, may separate notes ako sa formula. So, gaya nito sa fluid mechanics. No? So, nakaganyan na siya. Kasi masakit sa ulo kapag yung notes nyo ang ginagamit nyo pang isosolve kayo. Diba? Ang daming page no, nakakahilo magbuklat ng page, no? Lalo na pag mga handout po, daming bubuklatin. Unlike kapag summarize na or naka-concise na ng isang page, titingnan-tingnan mo na lang siya. Diba? Parang ganyan. Fluid mechanics 1, fluid mechanics 2. Ito yung diniscuss ko ngayon. Yan, fluid mechanics 3. 2 and 3 yung diniscuss ko ngayon. Yan, mga hydrodynamic force. So, ganyan na lang dapat, no? Nakalagay niyo na formula para hindi nakaka-stress pag nagsosolve kayo. Ewan ko kung sa inyo pero sa akin kasi pag marami akong binubuklat na page ng formula, nai-stress ako mag-solve eh. Nahihilo na ako bago pa maka 10 question. Pero ewan ko lang sa inyo. Sa akin lang kasi based on experience. So yun, as much as possible paki-concise, paki-compress yung mga formula para madali nyo siya makabisado. Especially pag mag-in-house kayo sa Prime, no? Hindi naman pwedeng dadalhin nyo lahat ng notes, no? Mga formula na lang yung dadalhin para, more on the next sub na lang ang nangyayari. Then, yung nomenclature ilalagay nyo din. Kasi pag walang nomenclature, malilito kayo sa mga given, sa pagkuha ng given. So, ganun lang naman. So, yun. So, quiz tayo sa Monday. Tama. Industrial plant, then Friday, yun na yung simulated 4 days. Computation ng grade, next week ko isa-send after ng exam. So, doon yung makikita kung nakalusot ka or hindi. Okay. So, may tanong pa ba?
Sir, pwede po ba kayo ng formula po sa fluid mechanics?
Sige. Sige. Isisend ko na lang yung formula ng fluid mechanics. Kahit yun na lang yung isulat nyo. Wag na yung PowerPoint. Kasi medyo mahaba yung sa PowerPoint. Okay. So wala nang tanong.
Sir, yung pasahan po ng notebook dito, sir.
Bago mag-simulated, so May 5. Yun yung deadline. Then yung activity number 3 nyo pala, no? Pakipasan na yung activity number 3. Ay, sa bagay, nilagyan ko na ng deadline yun. Dapat mag-send pa ako ng passport 2020 kasi tagal nyo magpasa ng activity number 3, so hindi na lang. Magagilap na lang kayo ng passport 2020. Yung bibigay ko na lang sa inyo yung math na passport 2019 and 2020. Okay, so wala nang tanong. Wala na ba? Okay, okay, open na yung camera.